Back in April, Stripe Payments released a new billing platform that makes complex subscription payments easier than ever. To demonstrate this tool, we're going to build a pretty ambitious feature, a subscription plan that doesn't get billed on a fixed rate, but rather based on the user's volume of usage within the app. The goal is to give you a foundation for building your own software as a service type application that has a pay-as-you-go payment plan. If you're new here, make sure to like and subscribe. And also, a little later today at 1 p.m. Pacific Time or 7 p.m. GMT, I will be appearing on the Angular Academy show, so make sure to register so you can live chat with myself and the world-famous David East. To get started with this project, you'll need to have a Stripe account, and we'll be making heavy use of Firebase functions. There's a new tool in Firebase that makes a feature like this much easier to build than it was a few months ago, and that's thanks to callable functions. Basically, a callable function is just like an HTTP function, except that it sends the context for the authenticated user. This is extremely powerful because it means you don't have to set your own authorization headers in the front end, or have to decode them on the back end, which means a lot less code to write and test. We'll be writing 3 different cloud functions, so let's walk through this step by step. The first one is an auth function that happens after the user logs in and sets up their account with a Stripe customer ID. After we have the customer ID set up, the next major milestone is to collect a payment source and sign up a user for the subscription plan. We'll implement Stripe elements to collect and validate the credit card from the user. Then when they click the Submit Payment button, it will trigger our callable function with the auth context so we can securely attach that credit card to the user in our backend. That signs the user up for the plan and writes a bunch of information to their Firestore user document, but at this point their estimated bill is 0 because they haven't actually done anything in the app. In this particular app, we will charge the user $1 per month for every project that they create. If we click this Create Project button, it will create a document in Firestore, which again triggers another cloud function. This third and final cloud function will report usage to Stripe so we know what to bill them for a given month. So if we create a couple more projects here, you'll see that our estimated bill jumps up to $3 per month. And we can also see this in the Stripe dashboard where we have an upcoming invoice for $3 for the subscriber. And we can inspect all of the usage events, which again will get reported via our cloud function. Before we write any code, let's start with the fun part, which is setting up the actual billing plan in Stripe. The first thing you'll do is set up your product, which is an entity that can hold multiple payment plans. So for example, a pro subscription would be my product, and then I might have multiple plans for weekly, monthly, or quarterly. For this demo here, we'll just set up a single payment plan, and we'll make sure to make it a metered usage plan. There's a whole bunch of ways you can customize the plan. For example, you might have tiers for different levels of volume usage, or you might have different ways of aggregating the actual usage through the payment period. The whole idea behind Stripe Billing is to allow you, the developer, to build a complex payment system without having to write a whole bunch of code to maintain it. When you're finished, you'll have a product ID and a plan ID. Make a note of the plan ID because we'll need that later in the cloud function. Now we're going to switch gears into our Angular app and initialize Firebase Cloud Functions. You'll want to select the TypeScript option, just go with the defaults and everything else, then cd into the functions directory, and run npm install stripe. Then the other thing we need to do is set up our Stripe secret key in the Cloud Functions environment. You can find it on the Stripe dashboard, and I would recommend using the test data so you're not actually working with live payment information. Then run Firebase functions config set stripe.secret with your secret key, and this will securely store it in our functions environment. At this point, we're going to be jumping back and forth between our front end and back end code, so I'll do my best to keep that clear, but the first thing we'll do is implement our front end user authentication code. I'm going to go over that quickly because I cover it in detail in episode 55, and this demo uses the same system with some slight modifications. I'd first like to point out that we have Angular Fire 2 installed, and we have auth, Firestore, as well as the new Angular Fire Functions module. So you'll want to make sure you have an app module that looks something like this. And you'll also notice that I generated a payment form component and project manager component with the Angular CLI that will build out here in the following steps. But the first thing we'll do is quickly go through the auth service to get our user logged into our Firebase app. One of the key differences from episode 55 is that we have some additional properties on the user interface, mainly the Stripe customer ID, as well as some information about the subscription itself. We have Angular Fire 2 installed here, so we can inject Angular Fire auth and Firestore in the constructor, and then we'll represent our user as an observable of a Firestore document. If the user is authenticated, then we'll go ahead and retrieve their document from Firestore. Otherwise, we'll just return an observable of null, which means the user's not signed in. The rest of this demo is compatible with any auth method in Firebase, but I'm just going to use anonymous auth because it requires the least amount of code to set up. What this code here is doing is it's logging in the user anonymously, and then it's creating a document in Firestore when they sign in for the first time. So all we have to do is bind this anonymous login method to a button click, and we'll get the user signed in without any additional work on our end. The next thing we want to do is trigger a function when the user signs up. So go into the index.ts file in the functions directory, and then we'll initialize Firebase admin, and we'll want to also initialize Stripe with our secret key that we set up in the environment earlier. And these variables are set up globally in this functions file because they'll be shared throughout our 3 different cloud functions. The first function is the easiest one to create. Basically, we're just listening for a new user to sign up, and when that happens, we'll take their Firebase user ID, use that to create a new user in Stripe, and then update the customer ID that we get back from Stripe on their Firestore document. So we're just creating a one-to-one connection between the Firebase user and the Stripe user. Authentication triggers in Firebase will include the Firebase user ID on the user record object. Then we'll call Stripe customers create, and we'll set their Firebase user ID as metadata on the Stripe customer. That part's technically optional, but it's generally a good idea to keep track of things between the 2 platforms. Stripe will respond with an object of the newly created customer, and the only thing we actually need from that is the Stripe customer ID, which we can then use to save on the Firestore document. So that takes care of the first hurdle. Now that we have a Stripe customer, the next thing we need to do is collect their payment source and then attach them to a specific subscription plan. To handle that, we'll use Stripe Elements, which is the quickest and easiest way to set up a payment form in your front-end UI. The very first thing you'll do is go into your index.html file and add the Stripe.js version 3 to the head of the document. Then we can go into our payment form component, and the first thing we'll want to do is initialize Stripe Elements, which really just operates outside the context of our component, so we'll just add it up here directly in the code. This time you initialize Stripe with your publishable key. You don't want to expose your secret key in your front-end code. And then we'll say Stripe Elements create card, which will eventually bind here to a DOM element. In Angular, we can grab an element from the DOM by using viewChild, which we'll call our card form. And we'll be using a callable function in this component, so we inject the AngularFire functions service. After the view is initialized, we'll call card.mount, which will have Stripe Elements do its thing on this specific DOM element. After the user fills out the form, we need to send the card details to Stripe, which will then respond with a token that we can use to attach the payment source to the user in our backend. For that, we can call Stripe create token, and I'm not showing it here, but you should also handle errors here as well. But assuming we have a valid card, we can then call our callable function, which we'll name start subscription. So this is an alternative to using the HTTP module in Angular. Normally we would have to set the authorization header for the logged in user and then decode it in our cloud function. So the beauty of a callable function is that we don't have to do any of that. We can just pass in the source that we get back from Stripe, and we'll already know the context of the user when this function gets triggered. Then if we switch over to the HTML, all we have to do is set up a form, and then we'll bind to the submit event on this form and trigger that handler that we just wrote. The only other thing to do is set up a div for Stripe Elements to attach to, which we can do with #cardForm. That takes care of the front-end code. Now we'll write the back-end code for that callable function. We can go ahead and say functions HTTPS on call, and that gives us access to the data that we pass from the front end, which is the Stripe token that we need to use to attach to the user. And again, we have access to the caller of this function, which we can get with context.auth_UID. Now that we have this information, we can go ahead and pull that user's document from Firestore, which contains the Stripe customer ID. So now we have all the information we need to attach the payment token to the Stripe customer. We make that happen by calling Stripe create source with the customer ID, as well as the token that we passed through this callable function. And while we're here, I'd like to point out that we handle errors a little bit differently than other HTTP functions. Instead of sending an error response, we can just throw an error directly, and the callable function will send that back down to the client. But assuming that the payment source attaches successfully, the next step is to subscribe this user to our actual plan that we created in Stripe at the beginning of this process. So we'll go ahead and call Stripe subscriptions create and pass in the Stripe user ID as well as the plan that we want to subscribe them to. I'm just hard coding it here, but most likely you would set that up as an environment variable or send it through the callable function. And lastly, that will respond with some data, and we'll use that data to update the Firestore document. So at this point, we have a system where the user can submit their payment and it updates their document with the subscription information from Stripe. The final thing we need to do is report usage to Stripe. Otherwise, we're not going to get paid for anything. So in this app here, I've set it up so the user can create a hypothetical project, which is just creating a new document in Firestore that lives in the projects collection. I'm not really going to focus on the front end code here because it's really simple, just adding a document to Firestore, but you can find the full source code in the link in the description. The interesting part here is our third and final cloud function. We'll call this the update usage function, and it will run whenever a new document is created in the projects collection. And the process is pretty similar. We have a user ID that's on that project document to associate it with the Firebase user, so we can then pull their Firestore document information, which has the subscription information that we need to report usage to. So we'll retrieve the user document like we did in previous functions, and then we'll call Stripe usage records create, and we'll create a new usage record with the item ID on that subscription. This can be kind of confusing because you might have multiple items on a single subscription. For example, think about the way Firebase bills. You have different quotas for storage, database, functions, etc., and you're billed separately for each. That's exactly the kind of stuff that Stripe billing allows you to do. You can send usage records to Stripe one at a time, or you can aggregate them together and send a higher quantity based on the amount of volume that flows through your app. You'll need to set a timestamp in Unix seconds, so convert the JavaScript millisecond date into plain seconds. Then it's always a good idea to set an item potency key, which you can do with the snapshot ID. That'll just guarantee that the user's usage will be consistent even if this cloud function gets invoked multiple times, which is possible. Then the final thing we'll do is update the user's record in Firestore just so we can show an estimated bill for them as well. Now, whenever you create a new document in Firestore, this user's bill will be updated, and then Stripe will charge them for it at the end of the month. I've been doing this for a while, and it's pretty amazing that we can build a feature like this in a completely serverless way and at zero cost for us initially when building our minimum viable product. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe, and don't forget to join us on Angular Academy today, again at 1 p.m. Pacific time. And if you're not already a pro member, make sure to sign up to get access to all kinds of exclusive content designed to help you build and ship your app faster. Thanks for watching, and I'll talk to you soon.